Hi everyone. My name is Trần Đức Trung. You can call me John Trần. I'm from FPT.University, Hanoi, Vietnam. Today I'm going to represent our research team to present our research paper titled End-to-End Conversion Speed Analysis of an FPT.AI-based text-to-speech application. We have done this work in collaboration between our university and University Technology Petronas and also Euro Federal University. Here is our presentation agenda today. First, we will go through the introduction of the research, then research methodology. Next is the results and analysis, and finally, there are some conclusions that we would like to draw from this research paper. First, as you know, automated responding systems such as chatbot and voice bot are commonly deployed in corporates nowadays. For example, in Vietnam, in the past 2 years, starting from late of 2018, there are several chatbots that were deployed to support activities of banking systems, especially in supporting the customer to address the customer's queries regarding certain information that the bank corporate are offering to the customer. So speech to text and text to speech technologies are developing recently, and they enable the more deployment of this kind of automated responding systems. In our research, we are focusing more on text to speech, for example, converting the text to voice of human. This will enable the application of this type of TTS to automatic calling machine. And currently, we are one of the leading. We are in the leading position for offering this kind of services in a Vietnam market. So, as you may know, the responding quality of the chatbot or voice bot system heavily depending on the quality of the input signal, and also it depends on the understanding of the request and context that the user are giving to the chatbot or voice bot. Of course, the quality of the response from the bot also depends heavily on the conversion engine. So there are several parameters that can be used to indicate the performance of a TTS application, such as mean opinion score, MOS. This MOS is widely being used nowadays to judge the quality of the voice generated from the TTS engine. However, as you may know, we are focusing on end-to-end customer solution. That means it's not only about the TTS, text-to-speech MOS, it is also about the responding time to customers' query. So this end-to-end conversion time was not really well discussed in recent research papers. This is the reason why we are focusing on this area. So in our research, we are using the FPT.AI-based API, which is offered by FPT Corporation. In this FPT.AI API, we actually have the free usage of up to 10,000 characters for text-to-speech conversion. So in our opinion, we think that this amount of text or characters is actually sufficient for us to carry out the research paper. And actually, we can create more free account to try the service offered by FPT Corporation. So the TTS application API requires 4 arguments to put into the HTTP header content to form the HTTP request to the server. The first thing is actually the post data, which is the text that will be converted to speech. The second argument is the voice. Actually, user can select several voices from the system. Until now, there are 7 voices that can be supported by the system. And the default one is the female voice. The third parameter or argument is actually the speed of the voice after generating the speech. By default it's set to 0. However, this range can be from -3 to +3. -3 means the slowest one, while the +3 is the fastest one. And then the fourth argument is actually the prosody. However, this is only available for question working with the male voice. We are not focusing on only male voice. That's why we do not use this prosody parameter. Currently, FPT.AI TTS supports up to 7 voices. The voices are ranging in regions from the northern part to southern part and to the central part as well. To develop the application of this TTS, we use the Visual Studio Code, HTML, CSS, Python language, Bootstrap, Django, and FPT.AI API. As you can see in figure 1 is actually our application structure. This is FPT.AI-based TTS application. You can see that we use the Django web application to generate the website and get input text, input speed, and also the voice from user. And all those things can be done in a local host. After that, we send a request to FPT.AI engine, which is located in a server remotely. And after the FPT.AI engine receives the request from us, from the local host, it will generate the speech and return the speech link to localhost. Based on the link, the localhost can download the generated speech and play it. And the link provided by FPT.AI is actually a static link. This means it will stay persistent over the time. And the return format file is MP3. One of the Django web application important file, which is the views.python file. In this views.python file, we have the algorithm to create the views, also to get the parameters and input from users. As you can see here, we have the parameters such as voices selected by user. Voices here. In this case, we use this input text as the voice from the HTML file, HTML user interface. It has the parameter of voice. We also have the speech voice we get from user, which is input from an HTML template. It has the variable name. Similarly, we can get the speed from user through the HTML page, graphical user interface. And after that, we append the URL into the header together with the API key. For each user generated by the system or registered through the system, we will have one API key. And each API key here we can use for converting up to 10,000 characters. There are other available services such as speech to text given the same API as well. Given the same account registered under FPT.AI. After we have the response, after we have the request sending to the server, we have the response. We can capture the response from the server. And then finally, we can render the request and upload the information to the web page, which is located at the localhost. And as you can see here, we have the application interface, which is written in HTML language. This page is actually hooked up or link up with the Django application as the backend. Here we have the title here. We have the area for inputting text. We also have the selection for the speed. By default, it will be 0. and user can select 7 different voices. After that, user can press the button speak. It will convert the text input here to the appropriate voice, and we can play back on the web page. So here it comes to the results and analysis. After performing the analysis with the end-to-end conversion time, we have 2 outcome or output which we want to discuss here. The first thing is the first end-to-end conversion time in comparison with the length of the text. For example, user may want to input several text, several characters, 20 characters, 100 characters, or even more. They may sometimes want to input even a web page into the text area just to read the overall web page using the technology. So in our case, we perform the test with 10 character, 100 character, 200, 300, 400, and 500 characters at the moment, at most. And after performing the analysis, we realized we performed the first conversion time we performed for 10 for 1 time, and we performed the measurement for 9 other times subsequently using the same characters. The first time we used, you can see that the overall conversion times ranging from 1 second up to 10 seconds. And we have 3 voices, which is Lanyi, Leming, and Ban Mai. These 3 voices cannot generate 500 character speech. And in special case for the 400 characters speech, Lanyi, for the first time, it cannot generate the speech or the voice. So this is later we will explain why there's a significant difference here. And when we perform the remaining comparison and also the data analysis, we have this plot which is this display in figure 6. Here it is the average end-to-end conversion time versus text length. You can see that the average processing time is very much different. It is ranging from 0.4 seconds until at most close to 1.8 seconds when for the case of Leming at 400 character. And at the 400 character Lanyi case, the average processing time is very small, which is just slightly 0.5 seconds, while the remaining average processing time is increasing almost linearly, as you can see here. So here people may wonder why the first time conversion is pretty much longer compared to the subsequent time. The reason is that the engine, the FPT.AI engine is offering or is preparing a static link for user to download the file after the conversion, and the time to make the file available is different from time to time. And since the link is static, we think that the engine is actually doing the conversion at the back end, and only after the certain time the link will be available. And since the link is static, it is useful for users to use the same text for conversion multiple times. For example, an application of it is that one user may want to read a web page, another user may want to read the same web page at the same time. Then maybe 10 or 100 users may also want to read the same web page with the same content. So by providing a static link with which is containing the conversion file of a given text, same given text, multiple users can experience the faster response time, you can see. So in our opinion, we think from 0.4 to 1.8 seconds in terms of the responding time is quite significant or quite acceptable for responding between the user and human, especially in speech. So in conclusion, we have presented a development of text-to-speech framework which can generate male and female voices based on FPT.AI engine. We can perform the conversion of up to 500 characters for input text, and the processing time on average is less than 1.8 seconds, while on average it will be it will be less than 10 seconds for the first time. And we have discussed the input text length versus the end-to-end conversion time. In the future, we will improve and to have more attractive graphical user interface and improve the voice quality. Thank you very much for your attention. If you have any questions, please feel free to let us know. We will address them. Thank you very much.